Welcome to Programming with Qt Widgets. In this episode, we will look at coordinate transformations. They make what otherwise would be rather tedious relatively trivial. I'll show you an example that, you better be good with your sinus and cosinus and tangents or whatever that's called in English for that example to be easy. But with QPainter operations, it is relatively easy. So QPainter has 4 operations built into it that are operating on what subsequent painting operations will look like. It has translate, which changes what 0.0 means. So if you translate to a given position, it basically means that you are pushing the what 0.0 in your new coordinate system means to that position. It's a delta, so if you already have translated, then it'll be in addition to all your existing translations. Then we have scale, and scale, that is basically your zooming. So a 2x2 rectangle, if you scale by a factor of 2, it'll be, 4x4. We have shear, which is the poor man's version of italic. So think of a rectangle where you take the topmost rightmost corner and the bottommost leftmost corner and you pull them in each direction. Then you'll have a tilted rectangle, and that's what shearing is about. So rotate, scale, shear, and transform. Which one did I not tell? Rotate? Well, rotate, of course. So rotate, basically take your coordinate system or your paper, if you want to think of it like that, and rotate it with this angle. Let me show you an example of this in action, which makes it all much clearer, I hope. So what you see here on the left is a piece of code that is drawing some rotated text. It takes a painter. The precondition on the painter is that it's been opened, so that you actually created the painter on this or on a Pixmap or on something else that you wanted to paint on, that it gets a number of degrees, whether it's float or double. These slides are relatively old, so please forgive me if rotate takes degrees. I can't remember. Then an X and a Y coordinate, I guess should have been a Q point, at least I would have written it as Q point today, and then the text. And what I want to do is basically like this. So I have a coordinate system, and you gotta love that coordinate systems in this world is pointing downwards, and all that you ever learned in your life is that they point upwards, but not in computers. And at this point here, I want to draw a piece of text. So what I do first is that I call save on my painter. I'll get back to why that's important in just a second. I'll translate to X, Y. So that's the position that I have down here. So now I have a new coordinate system where 0,0 is at this new point. And of course, there is negative coordinate too if I should ever need those. Then I rotate the amount of degree. And the cool thing about rotating is that rotating around 0,0 continues, or rotating means that 0,0 is the only coordinate that stays the same. So now I have a coordinate system that looks like this. I've rotated it, and I guess I can just turn it upside down, because now I want to write, I'll just write it here on top. At this position here, I want to write hello. So at this point that I had, I wanted to rotate text. Wanted to draw text rotated. Okay, let's look at the code here and see those things. So I translated to this coordinate here. I rotated it to the coordinate system, so what was previous looking at this now is looking like this. And then at that position, I draw the text 0,0. So in this new coordinate system that goes like this, I draw the text hello. Now imagine, see, I got a QPainter in here as a parameter. Imagine I wanted to draw some rotated text with at another position with another degree, I obviously need to hand my Cube Painter back because these were operations on the Cube Painter itself. So I needed to hand it back into a state that was as it was when I got it. And I can't just take a copy of Cube Painter and then operate on that because, well, it's a pointer I get into a Cube Painter, right? So what I could have done is that I could have done the opposite. I could have rotated it the opposite amount and then translated the opposite direction. But besides being a lot of work, it would also run the risk that there would be some rounding errors that would eventually scale up and my coordinate system would eventually look somewhat weird. But hopefully, I'll try again. But fortunately, that was the word I was looking for, behind the scenes, all these operations are really just matrix operations. So remember back to your school days when you learned about vectors. Well, 3x3 generalization of a vector is a matrix, well, a 3x3 matrix at least, and that's what it is behind the scenes. So we have these save and restore that will take a copy of that matrix and restore will get it back again. Save and restore will do a bit more than that. It will also take the pen and the brush and likely more things. So save and restore can be slightly expensive, which is why sometimes it's useful to just go straight to that matrix and do the operations there, which we'll see here on the next slide. So the matrix is represented by a class called QTransform. And you might ask, why not just QMatrix? That would make it much easier. Well, it in the really old day was called QMatrix, but it didn't have one facility that we'll see in a few slides. So they had to come up with a new name and, well, the old name was already burned. So it's called QTransform. As you can see here on the slide, QTransform simply takes 6 parameters and the math or the operations is that when I get an X and a Y coordinate in, then what I'll actually get out is the X multiplied by M11, the Y with M21, and then plus delta X, and then the Y coordinated, think of a new line here, the Y transformed is this operations down here. And I'll go back and see that in a few moments when I'll show you how to get your grid pointing upwards again, which is useful if you, for example, do get data in from somewhere in the real world where the axis points upwards rather than downwards as they do in computer science. So once I have that, my code looks like this. Again, my precondition is that my painter has been started. I can now go to the painter, ask for the transform. The transform, I'll make a copy of that so I remember the current setup. After all, it is just a 9 numbers that I remember here. And then on the transform, it fortunately has all these methods, the shear, scale, rotate, and the one I can't remember, shear, scale, rotate, transform. These methods are on the transform, translate, exist on the transform. So here I have exactly the same as we did before. Translate to this position, rotate this amount of degree, set the transform on the painter, the new transform I created, and then draw the text and then set the transform of the old transform. Yes, at this level it's micro optimization, but sometimes you have some operation that you cannot describe with only these 4 operations, or it's just too complicated, and then it's useful that you can get your hands on the actual transform itself and then use that. Otherwise, as I said, it's a good optimization. After all, painting code can be rather in a hot spot. If you, for example, resize the window, then a lot of painting will go on, and then you might get a few extra repaints per second by using transform versus just doing the transformation straight onto the painter and using save and restore. And just from switching from one frame to the next frame, I had a microsecond to check out Q matrix, and indeed in Q5.15 it says Q matrix is obsolete, and in Q6 it simply is not there anymore. The thing that Q matrix did not support that Q transform does is this thing called perspective projection. And let me just show you what perspective projection is. So here we have the coordinate system that we have, and we can rotate and we can shear. If I check here and I drag, and we can scale. I'm not going to ruin my perfectly good remarkable with that operation, but you get the idea. But here is the operation that Q transform can do and Q matrix couldn't. This one here. You can see this area here getting closer to you and this one getting further away, and you can see it can rotate all the way till it looks like this. And that is, as I said, perspective projection, which you get, and you can set that up by specifying. You saw the Q transform taking 6 coordinates, the connector take 9, and here is the operation. You have the x, y coordinate, and you multiply that on this matrix. It gives you this, which we all remember from our good old days when we did matrix multiplication by hand. And it gives you an x and y translated, and then a w, and that gives you this 2D result that gives you the feeling of something is closer to you, despite that it's of course still only in 2D. If you want to do this and you are not as brave as setting up this matrix here, then you can actually just do it with a rotate. In Q transform it takes an axis and an angle, and you can specify the y-axis, which will give you exactly this transformation that I did there with the y-axis there and the there, I guess, and the x-axis and z-axis and so on. So that is possible that way. I'd like to show you a real-world example of this, because this wasn't invented just to be able to draw translated text. But what you see here on the screen now is a clock that shows that it's about time for me to go down and have dinner. In Denmark, at least, we have dinner at 6 o'clock sharp, some of us. Anyway, this clock, I'd like you to pause the time now and think about how you would draw that clock with the knowledge that you have, minus transformations, mind you. What you likely came up to when you were pausing the 2 minutes to 3 minutes to dinner time was that you needed to do a lot of calculation and figure out sinus and cosinus, and how do you even draw this arm over here. Well, this is 0,0, so down here we have something, and you need to figure out how to do this. And that could be difficult if at least sinus and cosinus wasn't your favorite topics in school, but I'll show you how it works. And somebody told me this cannot be done in front of a camera, Jesper, so I decided of course it can, and I'll show you right now how it works. But please give me a second because I forgot my pen. A customer we had once went from one pie to the other, a raspberry to a banana. But that was not trivial. There was lots of loose end in the software stack for that. Stuff like the audio driver. If you ever find yourself in a similar situation, reach out to us. We might be able to help you. Okay, now with a pen, I will draw that clock in front of your eyes on a piece of paper, and you'll be amazed of how easy it is. I hope. The code is over here. I'm creating a Q painter on this. I want to paint on the widget. I'm inside a paint event. Hopefully you realize that by now. I'm setting the rendering hint to be anti-aliasing, which I think is the default, but anyway, good to do. And here comes one of the tricks. So I have a piece of paper here that I'm going to draw on, and you might actually already notice that there's something here stuck in the middle, and that stuck thing in the middle is the center of the paper. And what I'm doing is that I'm translating the width and the height divided by 2. That's what I translate to. So that means that this point here now is what? 0, 0. You're absolutely right. And I scale it to site divided by 200. 200, or the site divided by 200, which makes it, and see if I can do it here, which makes this one over here 100, 0, minus 100, 0, 100, 0, the coordinate system still points downwards, and minus, no, 0, minus 100, 0, 100. Okay, you get it now. Good. Let me scroll down to where I draw the hour marks of this clock here. And you can see they are done in this for loop that we have here. So I'm running through 12 hours in a day. And I'm drawing a rectangle. And you can see the rectangle is 73 at x 73. So we have 0 here. I'll bet you that this edge here is 73. And 0 goes through this one here. So minus 3, that's up there. And it's 16 pixels here, and 6 pixel height, which means that it will start at 73 and then end at, why did I do that? 89. It will start up here at minus 3 and end down there in plus 3. Let me draw that to you here on my piece of paper. I'll even fill it out for you just for your enjoyment. There is the clock. What? Oh yeah, okay, I'm not done with the 12 step yet, because now I'll rotate 30 degrees. And, well, it goes like this. I rotate 30 degrees, and now my coordinate that was 73 point minus 3 is sitting right here. So I'll draw that one. I will rotate. So see, we started here. Started here, we rotated, and I'll rotate again. Go here and rotate again. Go here, rotate and rotate and rotate. And when I'm done, oh man, you're never gonna guess what it's gonna look like. And I'm sure I'll get too many hours in the day now, because I couldn't count to 12 when I was doing this. So here we are. I started at this, and I rotated and rotated and rotated and rotated and rotated and rotated 12 times, and when I've done that 12 times, I have drawn all these hour marks. The same thing happens down for drawing the minute marks. Those there are 60 of, and this time I do not draw a rectangle as I did before. I just draw a line from 92,0 to 96,0, so 92 and 96 and 0, that's this line. I rotated 6 degrees, which is 360 degrees of a circle, divided by 60 hours, minutes, an hour. And that's this one here, this one there, and this one, and so on until I rotated them all. Finally, the code for actually drawing the arms up here is similar thing. I go and find myself a Q time, current time, that's the time right now, and I simply rotate. This must be the hour hand I'm drawing here. I take the hour plus a 60th of a minute, so that the hour hand actually moves around throughout the hour, and I draw my convex polygon for our hand, which is the one we have up here. Convex polygon for our hand. It is drawn like if it was at 3 o'clock, and due to the rotation, it works out again. And the comma 4 that we saw down there is because of this API. It takes not a vector, which you would possibly have expected, but a C array of Q points. So I need to specify how long was that. That's the comma 4. The minute hand, similar drawing. And now you ask yourself, but that's just for the current time. Well, come on. You know by now we have a Q timer. The timer is set up to go off every 1,000 milliseconds. So every second it goes off, it goes into the update method of my analog clock. It does take some getting used to think about transformations like this. And let me just be blunt and say, okay, I haven't done all that much painting, and when I do, I often end up, well, at least not doing the trick of scaling my coordinates so that it's easier to think of them. I myself in my code throughout have divided by, which I'm actually gonna do again in the example that you're gonna see in the next episode. I know, because I already recorded that example. Anyway, I promised you one more thing, namely you have these coordinates that in the real world the y-axis point like this, but in our world, widgets coordinates, they point downwards. So if you get some data in from seismologic surveys or whatever, and they point upwards because that's what geologists think of, transforming them is actually pretty easy for displaying them. Here's an example. See, I have a painter, I draw a line set window. We haven't talked about that, but that's the same trick as the scale that we saw. I'm basically saying, well, I'll be thinking of this up here as -100, -100, and the width is 200 and the height is 200, which means that when I draw a line from -100, 0 to 100, 0, it goes from here to here, and another one from there to there. And now I'm setting a pen to be blue, and just in case that you're colorblind, I'm also setting it to be solid, so it's this pen down here. I'm drawing from 0, 0 to 100, 100. That goes from here down there, because our coordinate system on the y-axis goes downwards. But if I set up a transform, then this matrix here is basically the calculation that we saw some screens ago here. Almost, there we are. Nope, where did that go? It was the wrong, where? There we are. Remember, x mark is equal to an x and whatever. So this is 1, 0, 0 in the math I showed you. And then y mark is -1, so minus y, and 0, 0. And that gives us this transformation down here on this slide by having a +1 and a -1 there. Now my +5 as a y will be -5 and vice versa. And therefore painter set transform with this transformation. Again, a red color that is dotted, and setting the pen of my painter to be this new pen here, and then painter draw line just as I did up here, but now it points upwards. That's it for this episode of Programming with Qt Widgets. In the next episode, I'll do something highly unusual. I will do some live coding. I'll show you a bar chart implemented in Qt using QPainter, and I'll do the live coding simply to give you a chance to think along, because showing you examples, you're just sitting there, but with live coding, you will actually hopefully think along. It's a trick that I do often in class. In regular classes, we have lots of exercises, and sometimes the students are just too tired to do the exercise, or mentally challenged throughout the day because we've been working too hard. So I'll say, let me do the exercise for you, and then I'll program on the projector so the class can follow along and still get some momentum. So that's what we'll do in the next episode. Until then, have a great time.